we've learned the IUPAC way to name esters. Now we're going to learn the common naming system for esters. Okay, so when you're naming common naming for esters, you're using the same exact pattern as IUPAC, except for the second word is going to use the common name of the carboxylic acid. So I'm going to start just by naming the IUPAC name and then showing how the common name is different. So we're still drawing our line in the sand. Okay, and the alcohol side is going to be your alkyl group. So here we still have a methyl group, and we're going to name the carboxyl side as the carboxylic acid. We're going to remove ic acid and add ATE. So this would be ethanoic acid changes to ethanoate. So this is the IUPAC name. So I'm going to follow the same rules for the common naming. So I'm still going to separate the alcohol side, the single oxygen side, from my carboxyl side, and I still name that as a methyl group. This time though, I'm going to use the common name for this carboxylic acid, and I'm going to add the ending ATE. So this would be acetic acid. I'm going to remove the ic acid, and I'm going to add ATE. So this is now methyl acetate for the common name. All right, on our second example, the IUPAC and the common are the same. So I am going to draw my line in the sand. This is my alcohol side, and it has 2 carbons. So this is ethyl for my alkyl group. And then I'm going to name the carboxylic acid, which is benzoic acid. Remove the ic acid. So this is benzoate. There is no difference between the IUPAC and the common name for this because we don't have a common name or an IUPAC name for that. It just is benzoic acid. So that only has a single name. All right, on our last example, I'm going to draw my line in the sand. I like to separate out my alcohol side, the part that came from the alcohol when the carboxylic acid and the alcohol reacted together in an esterification reaction, because that kind of shows me what I named first. So the single oxygen side is a methyl group, and using the IUPAC name 1, 2, 3, this would be propanoic acid. So this becomes propanoate. And now for the common name, nothing changes with my alkyl group. It's still methyl, but I'm going to change the prefix. So this would have been propionic acid. So I keep the propion, remove ic acid, and end it with ATE. So this is methyl propionate for the common name. So raspberries, one of the compounds responsible for the flavor of raspberries is ethyl formate, which also has a rum-like odor. So let's go ahead and draw the structure of ethyl formate. So I know that I have a single carbon carboxylic acid side, okay? Because that's the form in formate. And then the oxygen side has 2 carbons because it's an ethyl group. And I can't forget this single carbon is going to need a hydrogen on it so that it has 4 bonds. So this would be ethyl formate. There's my ethyl, and then a single carbon makes ethyl formate. All right, so benzocaine is an example of a molecule that has an ester bond, and it has the ester functional group. Benzocaine is the active ingredient in a lot of over-the-counter oral topical anesthetics, such as Oragel. So if you have tooth pain or mouth sores, you would put some of that topical anesthetic on it, and that would numb the area so that you don't feel pain. Another ester of importance is that found in non-acetone nail polish remover. So non-acetone nail polish remover has ethyl acetate in it. Let's go ahead and draw that structure. So acetate tells me that I'm dealing with a 2-carbon carboxylic acid. Okay, so this has 3 hydrogens, and then our ester bond, and it's going to have 2 carbons coming off of this single oxygen side. So this is ethyl acetate.